This is chapter 8. It's about integration of rational functions using partial fractions. Integration by partial fraction. Objectives: demonstrate improper integrals of functions by the methods of partial fractions. Demonstrate proper integrals of functions by the methods of partial fractions. Methods: for linear functions, use the natural algorithm. For linear functions, use the natural logarithm. For the rest, use the appropriate integration methods. Review. Find the following integrals. The integral of 1 over x dx. 1 over x dx. This integral is equal to ln of mod x. One more time, the integral is equal to ln of mod x. Let's find the integral of 1 over x minus 1 dx. And we do this using integration by substitution. So we take u equal to x minus 1. Then we do the derivative of both sides. So du equal to dx. And then we could just go ahead and do the integration of 1 over x minus 1 dx. It's going to be equal to integration of 1 over u, because we set u equal to x minus 1. So 1 over u, and then instead of dx is equal to du, so we replace that by du. And then we do integration of 1 over u du, which is going to be equal to ln mod x, just like if you just replace, instead of x here, you replace it u, and then you will get what we have over here. Then we could go ahead and replace u by the value we assigned to it, which is x minus 1. So this is going to be equal to ln of mod x minus 1. Since u is equal to x minus 1, this integration will take place because this is integration by substitution. Now we have review, and we want to find the following integrals. Example number 1. Example number 1, we have a rational function. Rational function, that means a function divided by function. So this rational function is x plus 1 divided by x squared plus 1 dx equals to, we know that we can split this into two functions. Since the numerator has x plus 1, so we could have x over the denominator plus 1 over the denominator. So we split them into two. So this is integral of x divided by the denominator dx plus integral of 1 divided by x squared plus 1, which is the denominator dx. Now, integration of this one, we can perform it as if the top function is the derivative of the bottom function. If that is the case, we could use log. So to make the top, which is the numerator, the derivative of the denominator, we have to multiply the numerator by 2. If we do so, then we have to divide by 2 to neutralize the 2. We don't want to change the value. So if we multiply it by 2, the numerator will take 1/2 of the result, because that's going to neutralize, cancel the impact of multiplying by 2. So now we can see that the numerator is a derivative of the denominator. Then we could apply ln, and this is what we do over here, 1 over 2, and then ln of x squared plus 1. That's the first part, integration of the first part. Integration of the second part, which is 1 over x squared plus 1, its integration is equal to tan inverse of x, of course, plus a constant, because this is not an integration that has limits. So when integration has limits, then we don't need the constant, but when it doesn't have limits, we have to put the constant. Now, let's go ahead and look at how this integration results in tan inverse of x. So to do so, since we have x squared plus 1, then that will bring our attention to the triangle. So if we have a triangle with angle theta and right angle over here, then the opposite to theta is x and its adjacent is 1. So the hypo will be square root of 1 plus x squared. Now we want to figure out a trigonometric function of this nature. And to do so, we're going to go ahead and get cosine, because cosine will give us 1 over square root of 1 plus x squared. Sine also will give it to us, but sine will complicate it by adding an x. We don't want an x. We want 1 over x squared plus 1. So if we get cosine, we'll get 1 over square root of x squared plus 1. And then we square cosine, and that will give us 1 over 1 plus x squared. Now we can see that instead of doing integration of 1 over x squared plus 1 dx, we can replace that by integrating over cosine square x. But then it is dx, so we have to find the equivalent of dx in terms of the theta, the angle theta, because this is cosine square theta. So to do so, we can see that tan theta, if we take tan theta, you go to the triangle, tan is the opposite divided by the adjacent. So tan theta is equal to x. Now we do derivative of the left side and derivative of the right side. Derivative of tan theta is equal to sec squared theta. And since theta is a function of x, then we have to do also d theta. So this is sec squared theta d theta. And then the right hand side, we'll do the derivative, and that's just give us 1, which is 1 dot dx, which is dx, so just 1. So now we can see that dx can be replaced by sec squared theta d theta. So over here, we replaced 1 over x squared plus 1, we replaced it by cosine squared because it's equal to cosine squared. And dx, we replaced it by sec squared theta d theta. Now we should be able to do the integration with respect to theta. But sec squared is equal to 1 over cosine. So you can see that we have integration of cosine squared theta multiplied by d theta over cosine squared theta, because sec squared is equal to 1 over cosine. So we can see that we can cancel out cosine squared. If we do so, we will have integration of 1 d theta, which is equal to theta. So the integration of the whole thing over here reduces just to theta, equal to theta. But now we have to figure out what the value of theta is. Since we have tan theta equal to x, which is, you can just one more time look at theta. Tan theta is the opposite divided by the adjacent. So tan theta is equal to x. Now we do tan inverse for both sides. We'll get tan inverse of tan theta equal tan inverse of x. Since tan inverse of tan theta, the tan will cancel each other, it'll give us theta. So theta will be equal to tan inverse of x. So if theta equal to tan inverse of x, then we know what we want to do next. So we have theta over here, which is the answer. So since theta over here is the answer, then we can conclude that the integral is tan inverse of x, because theta is equal to tan inverse of x. One more time. The integral is theta, but theta is equal to tan inverse of x. So the integral, this integral, which is eventually equal to x, theta, but theta we proved equal to tan inverse of x. So our integral will give us tan inverse of x plus constant. Now, if we want, it's right here. If we want to prove that this is the correct answer, we use the fundamental theorem of calculus. So we do differentiation of the integral. So if we did derivative of this integral, so the result of this integral is right here. So we have to do derivative of the result. So derivative of the result will give us d by dx. The result is 1/2 ln of x squared plus 1 plus tan inverse of x plus constant. But then let's get the d by dx inside and execute. If we do the derivative of this, we know that derivative of ln x is ln f of x is f prime of x divided by f of x. And f prime of x is 2x divided by f of x, which is whatever is between the modulus. So f prime of x, which is 2x, divided by f of x, which is x squared plus 1. But then we have half over here, so the 2 crosses with 2, and we end up having x over x squared plus 1. And then we have over here plus d theta over x, because tan inverse of x is equal to theta. So if we did d theta by dx, then we can figure out what is the next value, d theta by dx. But then we have tan theta equal to x. Tan theta equal to x. One more time, we have d theta by dx, but d theta by dx is same as derivative of tan inverse of x, and derivative of tan inverse of x is nothing but derivative of this function. So if we did derivative of this function, it's going to give us derivative of tan inverse of x, which is 1 over x squared plus 1. So it's right here, 1 over x squared plus 1. Now we can collect these two by unifying the denominator. So we will have 1 plus x squared, which is common between both of them. So 1 plus x squared divided by this is equal to 1, so that's x, plus 1 plus x squared divided by this denominator will give us 1 times 1 is equal to 1. So x plus 1 divided by 1 plus x squared. And this is what we started with, because the differentiation cancels the integration according to the fundamental theorem of calculus. So we did the integration of this function, we did its integration, and then we did differentiation of this integration, and we got back to the original function. So that proves that what we did is correct. Okay, let's get going then. Okay, now we have to look at the general rule for integration by partial fraction. A rational function is of the form f of x over g of x. There are two cases here. The first case is f of x greater than or equal to g of x. If that is the case, then we have to divide f of x by g of x and then find the integral. On the other hand, the other alternative is that f of x is less than g of x. Two possibilities only. F of x greater than or equal to g of x, or f of x less than g of x. If f of x less than g of x, we proceed by finding the integral. But if f of x greater than g of x, we have to divide f of x by g of x and then find the integral. Here is an example. In this example, this is example for f of x greater than or equal to g of x, which we said we have to do first we have to do the division of f of x by g of x, and then we will proceed with finding the integral. You can see that it is integration of x plus 2 divided by x minus 3. So x over here to the power 1 and x to the power 1, so they are equal. By equal we mean the order of the equation. So the order of the numerator is 1 and the order of the denominator is 1. Since f of x equal to g of x, divide f of x by g of x. So we do regular division. So x plus 2, that's f of x, divided by g of x, which is x minus 3. So x plus 2 divided by x minus 3 is equal to 1. 1 times x minus 3 is equal to x minus 3, and then we subtract x minus 3. So the sign of x will be changed and 3 will be plus. So 3 will be plus, add it to 5, and the change in the sign of x is going to cancel it. So the remainder is 5. Now we could replace this function by equal to 1. That is the answer, because that's the result of the division. 1 dot dx, and then minus, because we have a minus sign. So we have 5 over here. So it's going to be equal to integration of 5 over x minus 3 dx. This is going to be plus. So one more time, we said if we have integration of x plus 2 divided by x minus 3, since the order of the denominator is the same as the order of the numerator, that is f of x equal to g of x, because the order is the same, then we have to divide f of x by g of x. So we know that it's regular division, so we're going to go ahead and divide f of x by g of x, and for that matter this is what we're going to get. So x plus 2 divided by x minus 3 is just like x plus 2 divided by x minus 3. So we get the answer is 1, and that's why we put just 1 here, because x plus 2 divided by x minus 3 is equal to 1, and the remainder is equal to 5. So we already went through how this one is processed, but then we'll just jump over here. This is plus integration of 5 over x minus 3 dx. It's clear that integration of 1 dx is equal to x. And this integration is very clear, that's equal to 5. We take the 5 outside the integral, and then ln of x minus 3 plus constant. So this is the answer. One more time, we want to verify. So this is verify the solution using the fundamental theorem of calculus. So to verify that the integral of this is going to give me this, we're going to go ahead and do the derivative of this and the derivative of the resulting integral. Derivative of this is right here, which is d by dx of an integral of x plus 2 divided by x minus 3 should be equal to the derivative of this. So we'll take this one over here, right here, and then we do derivative d by dx of x plus 5 ln of x minus 3 between the mod plus constant. Derivative of x is equal to 1. derivative of 5 ln x, we just take the derivative of ln x and multiply it by 5. Derivative of ln x minus 3 is going to give us 1 over x minus 3, and then multiply by 5. So this is the 5. Now we can go ahead and collect these two. So we want to assume that we want to have a unified denominator between these two. So the unified denominator will be x minus 3. So we multiply, cross multiply, so we'll get what? X minus 3, and then this is 1 over 1. So this is equal to 1 over 1. Let's go ahead and fix this one. This one is equal to 1 over 1. Let's go ahead and do it. So this is 1 over 1. So cross multiply will give us x minus 3, and this will give us plus 5. And of course, both of them have the same numerator, which is x minus 3. So since the numerator is x minus 3, we subtract 3 from 5. We end up with a numerator of x plus 2 divided by x minus 3, which is what we want, because this is what we integrated. And then we took the integral and we did the derivative. We got back to the result. So that proves that the integration is correct. Let's go ahead and take another. In example 2, we went through a situation where the degree of the numerator is the same as the degree of the denominator. In this example, we're going to have the degree of the numerator, which is 3, greater than the degree of the denominator, which is 2. The same situation applies. So if the degree of f of x greater than or equal to the degree of g of x, then we have to divide the top, which is the numerator, by the denominator. So let's go ahead and, before we perform the division, this is the top, the numerator, and this is the denominator. Before we do that, let's just consider the division of 96 by 8. We always take the leftmost and then we divide it by the one that we have to divide, divisor, and it will give us the result. And then we do subtraction to get the remainder. Same thing, we look at what? The x with the highest exponent. We divide it you divide it by the x of the highest exponent of the denominator. So x to the power 3 divided by x squared is going to give an x. So we have to multiply x by x squared plus x by 3. So that's going to give us, between these parentheses, x cubed plus 3x. Since we have to subtract this from the first line, so subtraction of x to the power 3 from x to the power 3 is going to give us 0. And then the negative will change this 3x to negative 3x. And we have positive 3x, so this will give us negative x. So the result of division is x and the remainder is negative x. So we take x and integrate it by itself, plus we take the remainder and divide it by x squared plus 3 divided by the denominator. If you recall, for example, if I want the division, let's suppose that I put 6 down here. If 6, I want to divide it by 8, it's not going to divide, so 6 is the remainder. So we can say that the answer, let me do an example, real example. Real example will make you understand it better. Let's take a look at a situation where we have to do, for example, the division of 26 by, let's say, 8. 26 by 8 will give us 3, and the remainder is going to be equal to what? 2. So we can say that it's equal to 3 plus 2 over 8. We divided the remainder by the total. So 3 plus 2 over 8, that's going to give us the number that we want. So it equals 3 and 1/4. Okay, but what we want is really 3 plus 2 over 8. So the quotient will be by itself and the remainder will be divided by the divisor. So the divisor here is what? The divisor here is this is the divisor, this is the denominator. So we have the result of division is x. So we put x to integrate by itself. And then the remainder, we took it and we put it as a fraction. So this is the remainder to integrate as a fraction. Just like this integration, just like this division, it will give us, this is the quotient and this is the remainder relative to the divisor, 2 over 8. So this is the quotient and this is the remainder relative to the divisor, which is the denominator. If we want to justify that this is going to do the job for us, let's go ahead and take the integration sign outside. We will have what? X over 1. We'll take dx also on the other side. So we'll have x over 1 plus, and we have negative x over x squared plus 3 plus negative x over x squared plus 3, and dx is outside. If you cross multiply these, they're going to give you this integration of this. Cross multiply x cubed plus 3x, that is this, x cubed plus 3x, and then minus x, that is minus x, divided by x squared plus 3. And if you subtract 1x from the 3x, it's going to give you x cubed plus 2x divided by x squared plus 3, which is this x cubed plus 2x divided by x squared plus 3. Now that we justified that this division will give us two parts of the integration, we could proceed with integration. Integration of x will give us x squared divided by 2. And then we have over here integration of negative x divided by x squared plus 3. Since we are not too far from doing integration by the ln, then we have to make sure that the top is equal to the derivative of the bottom. And the only thing that we need is to multiply by 2, the top, and then to divide by 2 so that we will not change the problem. So if we put 2 over there, then the numerator will be the derivative of the denominator. So if we put 2 over here, if we put 2 over here, then we will have 2x. 2x is the derivative of x squared. So since we have 2 on the top, we put it right here. And to make sure that we're not changing the problem, we multiply by half, because 2 will double the result of integration. So we multiply it by half. And since x is negative x, we could just go ahead and take the negative outside. So it will be negative half integration of 2x divided by x squared plus 3. Now this is ready to go as ln because everything works fine. This is the bottom and this is a derivative of the bottom. So that will qualify this one to have an integral equal to ln of the modulus of x squared plus 3, or the absolute value of x squared plus 3. Actually, we don't need to use absolute value because x squared is always positive and 3 is always positive. But anyway, we'll just do it for consistency. So we have negative half ln of x squared plus 3 plus constant. So that is pretty much the answer. Now, if we want to make sure that this is the correct answer and our answer is correct, what we can do is we can just do the derivative of the answer. If you did the derivative of the answer and the derivative went back to what it is, then the answer is correct. And that we can say we can use what? We can use the fundamental theorem of calculus. So fundamental theorem of calculus say if you did the derivative d by dx of the integration of any function like x cubed plus 2x divided by x squared plus 2 dx, it's equal to, must be equal to the derivative d by dx of this, okay, because this is the integral. So these two will cancel each other, and we have the numerator divided by the denominator. We have to do the derivative of it is integral. If the integral after derivative of the integral, if we receive the same function, then we're in a good shape. So let's go ahead and execute the derivative. So d by dx of x squared over 2 will give us x. And then we have negative half, so this is the negative half. And then d by dx of ln of x squared plus 3, that's going to give us what? X squared plus 3 in the bottom and its derivative on the top. That's the derivative of ln x. Okay. Since we know that what we did is to find the ln x, we integrated this. We integrated 2x divided by x squared plus 3. We integrated to get ln x. So if we did the derivative of this, it's going to give us the derivative of ln x. Derivative of this, that means just remove the integration part. We have 2x over x squared plus 3. And derivative of this, what we are looking for. So this is derivative of that. So that's going to give us 2x over x squared plus 3. Now we have the 2 goes with the 2, so we can cancel these. And once we cancel them, then we will get x minus, these are just signs I just made. We're going to get x minus x over x squared plus 3. And the 0 is because of the constant. Derivative of the 0 is equal to constant, but it doesn't matter. So now if we cross multiply, one more time, if we cross multiply, let's just put this divided by 1. If we multiply these, we will get x to the power 3 plus 3x. So x to the power 3 plus 3x. And then we cross multiply the other side, we'll get negative x. So this, if we subtract x, 1x from 3x's, it will give us 2x's, which is this. And we have x to the power 3. So this is also x to the power 3. So we have x to the power 3 plus 2x divided by x squared plus 3, which is what we started with, which proves that our method of integration is correct and the answer we got is verified. That's it for this one. Let's move on to the case when we have f of x less than g of x. I have another example. Now we're going to f of x less than g of x. Now we don't have to do any division. So when f of x less than g of x, here are some notes here. If a fraction of the denominator, is x plus or equal to a, that means x plus a or x minus a, represents the fraction by a over x plus or minus a. This is the method. What do we mean? We mean if we have a linear function and it's irreducible, then we represent it by a over that linear function. It doesn't have to be a, could be b, could be c, could be d, could be whatever. So we just have to represent it by something that represents the denominator. Let's call it a or b or c or whatever. We will see how this one goes in a minute. So you can use any uppercase letter for the numerator as long as its denominator is a linear function and it's irreducible. If the function is x squared plus or minus a, then we have to represent the function by not a over the function, but ax plus b over the function. Whether the function is plus or minus, it doesn't matter. Okay, so that is the second case. The third case, if we have repeated root, this is called repeated root. If we have repeated root x plus or minus a, then for the repeated root, we're going to get a over the first, which is to the power 1, the same bracket to the power 1, plus b over the same bracket to power 2. If we have power 3, then we'll have plus c over x plus or minus a all to the power 3 and so on. So the number of terms is equal to the power. Now that we've gone through these, this is just about the number of terms and the power, the relationship. Let's go ahead and take an example. Here is an example, example 4. It says 5x minus 7 divided by 3x minus 1 multiplied by x plus 1. So we know that 3x minus 1 is irreducible. We cannot reduce it any further. And x plus 1, we cannot reduce it. Both of them are just linear functions. So we can just put what? A over 3x minus 1, that's the first, and then b over x plus 1. So we split these into 2 and then we put them that way. Now we could just go ahead and regroup these. To regroup this, we will have a common denominator. So the common denominator is the multiplication of these two, and then we cross multiply a multiplied by x plus 1, which is right here, and then b multiplied by 3x minus 1, which is right here. So if we do the evaluation of this, okay, let's just concentrate on the numerator, because this is the denominator and it's equal to this denominator. So if we want the integration to give us the same value, then we have to equate the numerator with the numerator. Otherwise, just the denominators are the same, but numerator is different. We cannot get the same result for the derivative. Derivative integration of this is not going to be equal to the integration of this. So having stated so, we will just take a look at the numerator of the left, which is 5x minus 7. Should be equal to the numerator of the right. Now we're going to execute a in the bracket, so it will give us ax plus a, plus execute b, it will give us 3bx minus b. Now we will rearrange the points. So we have ax and we have 3bx. That means a plus 3b all multiplied by x, plus we have a minus b, which is not multiplied by anything. This is a constant. So if we have to have these two equal, that means a minus b must be equal to 7. And a plus 3b must be equal to 5. So we'll put 5 equal to a plus 3b. And we put negative 7 equal to a minus b. Now, subtracting negative 7 equal to a minus b from 5 equal to a plus 3b. Here is 5 equal to a plus 3b. We're subtracting from it minus a minus b and minus 7. So minus with minus will give us plus. And the negative here will cancel a with the a, and we'll get 3b minus b we get 3b plus b, because when I execute, the negative a will be negative, but b will be positive. So b is positive. This is 3b plus b will give us 4b. And on the right hand side will give us 12. You can check it out. This means that 4b equal to 12. That means b is equal to 3. Now b is equal to 3. We can get a. We said a minus b is equal to minus 7. But then we said b is equal to 3. So a minus 3 is equal to minus 7. So if a minus 3 is equal to minus 7, that means a is equal to minus 4. So now we know a is equal to minus 4. We know b is equal to 3. So we'll just go ahead and replace a and replace b. So our integration of the left hand side, which is this integration of this right here, left hand side, equal to integration, we're going to replace a by its value, which is negative 4. We just argued that a is equal to negative 4. So negative 4 divided by 3x minus 1 dx plus we have 3 over x plus 1. 3 is for b. Okay. So we have b is equal to 3. So this is integration of b, which is equal to 3 divided by x plus 1. Now the integration is going to be as follows. We can take negative 4 outside. If we take negative 4 outside, then the numerator must have value 3. Otherwise, the numerator will not be equal to the derivative of the denominator. So that's why we take the negative 4 outside, and then once we take the negative 4, we will do the integration, but then we have to multiply by 3. So if we multiply by 3 over here, that's going to give us ln of 3x minus 1. And since we multiplied by 3, we have to divide by 3, and that's why we get negative 4 over 3. So negative 4 over 3 ln of mod 3x minus 1 for the one in the right. The one in the left, we just take the 3 outside and then get the ln. So 3 ln 1 plus x plus constant. You can go ahead and verify this, and you should be able to, if you did the derivative, you should be able to get to the original problem. I'm not going to do it. Just go ahead and do it as an exercise. If you have any questions about it, just give me a call and I'll be happy to help you. Example number 5. Example number 5, we have x plus 1 divided by x cubed minus x squared plus x plus 1. So this is integration. F of x is less than g of x, so we're okay. We can just go ahead and proceed. But then first thing, we have to factor the denominator, because this denominator is not factored. We have to factor it until we have all the terms irreducible. So this is the denominator. It is going to be equal to x squared plus 1 multiplied by x minus 1. So we could just go ahead and replace this numerator by its factors. So we have x plus 1 divided by x squared plus 1 multiplied by x minus 1. Okay, so we're going to go ahead and split this function into two parts. Since this is x squared, as we said, the rule states that we have to put ax plus b on top of x squared plus 1. So ax plus b is the numerator of x squared plus 1, because it's x squared over here. This is complex function. And then this is linear function, so we'll just say plus c over x minus a. Now we have to cross multiply. If we cross multiply, the denominator will be x squared plus 1 multiplied by x minus 1. But then we have what? Ax plus b multiplied by x minus 1, which is right here. Ax plus b multiplied by x minus 1. Then plus cross multiply these. C multiplied by 1 plus x squared. So C multiplied by x squared plus 1. Now one more time, we just want to take a look at, since the denominator is the same for both, we just make sure that the numerators are the same, otherwise the integral will not make sense. So x plus 1 must be equal to, now if you multiply these, you're going to get what? Ax squared minus ax, so ax squared minus ax, and then bx minus b, plus bx minus b, and over here we have cx squared plus c, so cx squared plus c. Now we can collect the terms that have the same exponents. This is x squared, this is x squared, so it is a plus c multiplied by x squared, plus the points that, the values that multiplied by x only. So a is multiplied by x but is negative, b is multiplied by x which is positive, so we put b minus a multiplied by x to the power 1, plus the term that is constant, free of x. We have what? We have c and we have negative b, so it's going to be c minus b multiplied by x to the power 0. Now we can go ahead and read. We said 0 equal to a plus b. Why? Because a plus b is multiplied by x squared, but to the left x squared is multiplied by 0. So the coefficient of the x squared over the left is 0. Coefficient of x squared in the right is a plus c, so a plus c, 0 equal to a plus c. Similarly, b minus a is coefficient of x to the power 1. X to the power 1's coefficient is 1, so 1 is equal to b minus a. And by the same token, we can say that c minus b, which is the constant, is going to be equal to what? Is going to be equal to the constant, which is 1 multiplied by x to the power 0, which is constant. So 1 will be equal to c minus b. Now 1 is equal to c minus b, okay, and we have a plus c equal to 0. That means a is equal to negative c. A plus c equal to 0. That means a is equal to negative c. So a is equal to negative c. We're going to change this a into negative c. So we will have what? B minus, and then instead of a, negative c. So minus negative c will make it b plus c. So it will make it b plus c, and the left hand side will have 1. So 1 is equal to b plus c. Now we have also 1 equal to c minus b. We can just change them in positions. So we say 1 equal to c and then plus negative b is the same as c minus b. Now we can add these terms together. We'll get 2 on this side. The b crosses with the b, and we have 2c. So 2 is equal to 2c implies c is equal to 1. But then we said a is equal to negative c. So a will be equal to negative 1. And b is going to be equal to 0. Because 1 is equal to c minus b, and c is equal to 1. So b must be equal to 0. So b is equal to 0. Now we want to do the integral. We know the value for a and the value for c, and b is equal to 0. So the b is not anymore a factor. Okay, so it will be integration of a, which is equal to 1 multiplied by negative 1. A is negative 1 multiplied by x, so negative 1 multiplied by x is right here, divided by x squared plus 1, plus integration of c is equal to 1, so it's equal to 1 here, divided by x minus 1 dx. Now we also have to do the same thing that we've been repeating. We have to multiply the denominator, take the negative outside, and then multiply the numerator by 2, because That's the only time when it's going to be equal to the derivative of the denominator. One more time. The top must be the derivative of the bottom for the integration to be equal to ln. So there is a 2 missing here, so we'll multiply it by 2 and take the negative side and divide by 2 outside. So that's why we'll have negative half, and then the result of the integration will be ln of x squared plus 1 plus integration of 1 over x minus 1. This will just going to go ahead and log it, ln of mod x minus 1 plus constant. Now let's verify this. To verify it, we just do the derivative of this. If the derivative of this is equal to the function under the integration, then we're okay. So derivative of the first, okay, derivative of the first is we have the negative half, and derivative of ln x squared plus 1 is equal to x squared plus 1, and on top of it 2x. And then this is plus derivative of ln is x minus 1, on top of it is 1. 1 is the derivative of x. 2x is the derivative of x squared plus 1. Okay, so now we have the 2 goes with the 2, and we will have negative x. So negative x on the top divided by x squared plus 1 plus, and we have 1 over x minus 1. If you cross multiply, you will get x squared plus 1, right? X squared plus 1, which is in the other side. You cross multiply over here, you say negative x squared plus 1. You multiply negative x by x minus 1, it'll give you negative x squared plus x, because x, negative x by x is x, negative x squared. Negative x by negative 1 is plus x, and then over here plus x squared plus 1. So this is plus x squared plus 1. Now if you do the math, you can see that it is negative x squared plus x squared plus 1. Okay, and this is divided by x squared plus 1 multiplied by x minus 1. Negative x squared cancels x squared. If negative x squared cancels x squared, we will be left with x plus 1, which is what we need, x plus 1. And that wraps up this one. Let's go ahead